All right, Chem 11 students, this is our final talk in terms of molar chemistry. Well, not really, in a way. It's our final talk in converting between moles and mass and number of particles. Those have been the topics of the last few videos. But in reality, we're going to be using moles for the next number of lectures. This entire unit's going to be built upon moles. And you'll be using moles in grade 12 as well in university or college. And then if you go into the chemical industry in one way or another, whether it be a food company or a pharmaceutical industry or whatever it happens to be, moles are going to be all over the place. So it's something that we need to know. It's very, very important. It's number 3 in terms of the top, most important things that we have to know. Names and formulas is number 1. Balancing equations is number 2. And then number 3 is the mole. So, if we look from our last couple of lectures, all right, what do we have from those? Well, we talked about particles, right? And we talked about grouping particles in a specific number, 602 hexillion, and we said 602 hexillion particles is a mole. And we were converting back and forth between moles and the number of particles. And we had a conversion factor. And that conversion factor was knowing that there was 6.02 times 10 to the 23 particles per mole. And we said, well, to go from particles to moles, we simply divide. And to go from moles to number of particles, we multiply by this conversion factor, and that will give us the number of particles. And then the last lecture, just previous to this, we took moles, and we said we can convert the moles of a substance into mass. We said this makes sense to find mass, right? Equations use moles as their coefficients, but goods are bought and sold and supplied based on mass and paid for based on mass. And money talks, so we got to be able to convert moles from a given equation into mass. So we were able to convert moles into mass, and of course take mass and convert it back into moles. And the conversion factor there was grams per mole. The molar mass, right? The number of grams it takes for 1 mole of a substance, if you put it on a scale, the number of grams that it would weigh. Anyway, and this was multiply and this was divide. So we learned about this first circle a couple days ago. We learned about this one yesterday. Now moles is in the center of the whole thing, right? Moles is part of both circles. So I put the 2 of them together just like this. And today what we're going to be doing is starting either at this end with mass. So we're given this a certain mass of a substance and we've got to find the number of particles, or I could give you the number of particles of a substance and we can find the mass. So we're going from one end to the other. It's no longer just a simple jump from here to here or from these 2 right here. So we're going from one end of this thing right over to the other. So I'm going to do 3 practice problems with you today. Hopefully they will help you out with the sheets that we have to do that you can find on the D2L class for our course. And let's go to it. So our first problem. Now that circle, that continuum, right? Pause the video at that point where I had that down. I should have told you that, but pause the video and write those down on the back of your periodic table. I believe I told you to do that maybe yesterday. I'll write down our first question. What you're going to need to solve the questions today, you're going to need a periodic table. So I've got one here because to figure out the molar mass, I need the atomic masses of the elements that are used in the formulas of the substances that I'm working with. So I've got my periodic table, and you'll also need your trusty calculator. I just picked up this baby at the Dollarama today, one of the best stores on earth, right? And if you look at it, it's solar powered. So when the apocalypse happens, who's still going to be able to do quantitative chemistry? This guy right here. Anyway, so we'll put that there, and we will get to work on our first problem. So I'm just going to grab a couple of different colors for my markers here. so we can highlight specific things. Now, our first problem. I'll write it out quickly. Stock boy drops a box of baking soda with a mass of 250 grams on the floor. How many molecules of baking soda does he have to clean up? All right, so stock boy to grocery store, he's packing the shelves, drops a box of baking soda, looks at the box, it's a 250 gram box, it's all over the floor. How many molecules of baking soda does he have to get off the floor right now? So what do we need here? Well, the first thing that we're going to start with, that's important right there. All right, that's our initial value. That's what we're starting with, mass. How many molecules? So we know we're looking for particles. And baking soda. Now, baking soda, if I do a quick Google search, it's called sodium bicarbonate. So baking soda is sodium, and then bicarbonate is like carbonate with the hydrogen in front of it, if you remember. They both have a charge of 1, so that formula is absolutely fine the way it is. So I will do my answer in blue, pretend I have a blue pen. So if we think about our continuum, right? We have mass that we are given, and we have to turn it into particles. Now, if you look at that continuum, the two circles that we started off the lecture with, I can't go from directly to mass to particles. It's not a one-way trip. All right, so it's not like the arrow would represent here. Moles is in the middle. So it's really a two-part journey here. I've got to do one calculation, and then I have to do a second calculation to arrive at my answer. So I got to use both of those circles. So let's start with what we're given. I always start with what we're given. We're given 250 grams. So 250 grams is what we are going to start with. Now, off to the side somewhere, if I'm going from grams, which is mass, I've got to turn it into moles. That means I need the molar mass. The molar mass was a conversion factor in that loop. The molar mass, if you remember yesterday, was taking the parts of this, going to your periodic table, and using the various molar masses of the compounds involved. So I'd use NaHCO and 3. So I'll do that very quickly off to the side here. All right, so let's do that. So I've got NaHCO3. Na is 2299. H is equal to 1.01. Carbon, 12.01. And 3 times the oxygen, which is 3 times 16. And I'm going to add all of those together. And when I do that, I'll end up with 84.81 or 01 grams per mole. All right? So I add up all of these elements, 1 sodium, 1 hydrogen, 1 carbon, 3 oxygens, 84.01 grams per mole. That's my molar mass. So what I'm going to do now is I'm going to put that here, because I know the molar mass is the conversion factor between mass and moles, go figure. Now again, if I forgot what I have to do, I got to think, well, what's going to help me cancel? I've got grams on top and grams on top. So I have to divide. Grams divided by grams is no grams. And that will help cancel them out. If the grams was on bottom, I would multiply to get rid of it, but they were both on top. Whenever I have two units that are the same on top, or both of them on bottom, divide is going to help you get rid of that. So, the only unit I have left is moles, and when I run that calculation, I get 2.98. All right. I'm not done. It didn't ask for what amount. It didn't, moles is amount. If you get amount in a chemistry problem, they're talking about moles. Here it's asking for molecules. That's a particle. So right now, I'm only here. Right? I took that first step. I've got to get to the second step here. So I'm just going to carry this down here. 2.98 moles of sodium bicarbonate. And now I'm going to take the second step of the problem. And I know the conversion factor here was knowing how many particles was in a mole. So 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd. And it's not particles, it's molecules. Molecules. That looks pretty sloppy. Apologize for that. Molecules in a mole. And now I look, even if I wasn't sure, I know that it's multiply. But even if I wasn't sure, I'd go, in my head, moles is on top and moles is on bottom. To get rid of that, because I'm looking for molecules, I want to keep this, I have to multiply to get rid of that. And that'll help me get rid of the moles. And then that will be my final answer. I put it here normally, but I worked that out here. So my final answer is 1.79 times 10 to the 24 molecules. So that's how many molecules of sodium bicarbonate or baking soda are on the floor if all 250 grams end up spilling out of the box. All right, so this is our final answer. Now remember, when you're doing some of these calculations, brackets around this thing might help you out depending on what type of calculator you have. All right, so that's our first problem done. What I would ask you now is pause this if you want to get it down into your notes as a sample problem, and then I'll set up the second problem we're going to do. All right, our second problem, I'll write it in black here. There are 9.55 times 10 to the 22 molecules of aluminum chloride in a beaker. What is the mass of the aluminum chloride? So again, let's think this out. Let's think of what we got to do, okay? First of all, if I have a highlighter or something like that, I'm going to underline the important stuff. Well, there's the only value in the question. So that's important. Aluminum chloride is our substance. I'm going to use the formula of aluminum chloride to find the molar mass of it, right? I use that formula and add up the pieces. So knowing what you're working with is important here, aluminum chloride. And of course, our question is, what is the mass? So what we're doing here is we're starting with particles, and we're going to mass. Now again, I've drawn it like it's one calculation, but we know better. Moles is in the middle here. So we're going to do one calculation, our first calculation, get from the number of particles to moles, and then a second calculation to get us to mass, which will be in grams. All right, so this is another two-step operation. So let's do that. I'll get my blue out, just like a blue pen. And so we'll go, the first thing I've got to do is I've got to figure out what aluminum chloride is. So aluminum chloride is AlCl3. Again, I'm using this formula to determine my molar mass. If I mess up with this, I mess up my molar mass, which I'm going to be using in this calculation. So I have to be careful. And that's why names and formulas, doing them correctly, is the #1 skill in chemistry. You got to know how to do that. So if I look at this, I've got an Al on my periodic table. The mass of aluminum is 2698, and I've got 3 Cl's, which is 3 times 3545. So I add that all up together, and I get 133.33 grams per mole. So I'll keep that in mind. That's my molar mass right there. Grams per mole, molar mass, right? I always start with the first thing they give me. So the only value I have is 9.55 times 10 to the 22 molecules of aluminum chloride. I'm going to use my conversion factor between particles and moles. And that is, I know that there's 6.02 times 10 to the 23rd particles, but my particles now is molecules per mole. So we look here, molecules is on top here, it's on top here. I have to divide in order to do that. All right, so I'm going to divide that out. I put it into my calculator. Molecules on top, molecules divided by molecules, both are on top, they will cancel. I'll be left with moles. It's the only unit left. And when I do that, I'll squeeze it in here, it's 0.16 moles. Now remember, when we're doing this, whenever we're using the exponents, the big numbers here, that's 9 and that's 6. But this is 22, which is smaller than 23. This power number, the exponent here, are the more important ones. So even though 9 is greater than 6, because this has a higher exponent, this is a larger number. So we have less than a mole here, right? A mole is 10 to the 23. This is 10 to the 22. So our answer is less than a mole. So it actually makes sense, right? Remember, think, Ricky, think. All right. So I'm going to carry this down. I can't go any further there. I'm going to run out of space. So 0.16 moles of aluminum chloride. The next thing I'm going to do, so that's my first calculation, gets me to moles, so I'm here. My second one is to take my moles, this value, and change it into mass, which is what the question was looking for. And I'll need this molar mass in order to do that. So 133.33 grams per mole. If I look at this, even if I didn't know what I'm going to have to do, I know that I'm going to have to multiply this. But even if I didn't know, moles on top, moles on bottom, to cancel out something on top and something on bottom, I need to multiply it. And what that'll do is it will cross out the moles. All right? And I'll be left with grams. So I know my answer is going to be in grams, which is mass, which is what we're looking for. Beautiful. So when I divide that out, or sorry, when I multiply that out, it's going to be 21.33 grams of the aluminum chloride. All right? Easy enough? So again, we're going from one far end of the continuum to the other end. We have to hit this stop in the middle. So one calculation gets us to moles, and then a second calculation gets us to the mass. All right? Pause this video now if you want to get that down or take a look at it. And, you know, sometimes taking a second look or delayed look at it will help you out a lot more. I will set up our final question. This chemistry is not that hard. The two most common problems: people messing up a formula. So AlCl3, I'll get AlCl. And that messes up the molar mass. So a screwed up formula, that's a problem. The other one will be, I should have multiplied the two numbers and I divide it instead. So be careful what you're doing. Think about what's going to cancel something out better and do that, okay? So our last question. A bottle contains 325 grams of lithium phosphate. How many lithium ions are in the bottle? So, excuse me, we've got a bottle of lithium phosphate, all right? And it has 325 grams of this lithium phosphate, and it's in that bottle. So our question is, how many lithium ions? I'm asking about one particular part. So again, let's underline or highlight. This is important. That's my mass. That's my starting point. Lithium phosphate, that name I can turn into a formula and get the molar mass from that. And then this is what I'm looking for. Now, ions are another type of particle. So it would seem that we're doing this. It seems like I was given if we kind of reason it out, I was given a mass and I have to find particles. And you're thinking, oh, it's another one of those two-step things because you can't go straight through there. Moles is in the middle of this thing, so we're going to convert mass to moles. That's our first calculation. And then the moles to the particles, because ions are a particle. An ion is a charged atom. That is because it gained or lost electrons. We know this from grade, I think, 9 or 10. We went over it again in grade 11. But this is not the case. This one actually has an extra step on top of these two. And the reason is this. This mass is not of lithium. It's not 325 grams of lithium. It's 325 grams of lithium phosphate. So when I take that mass at 325 grams and I turn it into moles, I have to turn it into moles of what the 325 grams is. And it's this. It's lithium phosphate. It's not just lithium. So this will be moles of lithium phosphate. And then I'll turn that into molecules of, well, if it's moles of lithium phosphate, it has to become molecules of lithium phosphate. Then I've got to change the molecules of lithium phosphate to molecules of lithium ions. So that's going to involve a third step. All right? So lithium, those ions right there. So there's going to be a third step here. How we do that, we'll see in a moment. But let's do these first two, because we're pretty good with these first two right now. So again, the first thing I'm going to do is I'm going to change lithium phosphate into its formula. So lithium phosphate is Li3PO4. This is a 1, it goes there, that's fine. The PO4 is a charge of 3, it comes there. Again, names and formulas, folks. Gotta know how to do them. Anyway, so here's what we're going to do. We'll figure out the molar mass of this. So I've got 3 lithium, which is 3 times 6.94. And then I've got 1 phosphate, so I had 3 lithium, 1 phosphate, 30.97. And again, these values are right off of the periodic table. Lithium, 6.94. Phosphorus, 30.97. And I've got 4 oxygens, which is 4 times 16. So you can do this off to the side. I've got limited space, so I've got to kind of put it there. Anyway, I add this up, 3 times that, 4 of those, and 30.97, and I end up with 115.79 grams per mole. All right. So 115.79 grams per mole. That's my molar mass of this. I'll need this right here. Whenever I go between grams and moles, I need the thing that has both grams and moles in it. So again, I'm going to start with what I'm given. So 325 grams, and I'm going to divide by the molar mass. 115.79 grams per mole. And I know that grams divided by grams will cancel out those grams. So grams divided by grams is no grams, and I'll be left with moles. And when I do that, I put that into the calculator Matic 3000, and I get 2.807 moles. And that's moles of lithium phosphate. It's not lithiums. Remember, that mass is for lithium phosphate. That's the molar mass of lithium phosphate. So this is moles of lithium phosphate. It's not lithium ions. Excuse me. So that gets me to moles. I've got moles right here and here. My next thing, step 2, change it to particles. So 2.807 moles. And again, my conversion factor is 6.02 times 10 to the 23 molecules per mole. All right. It's molecules, not ions yet, because this is a molecule. And that's what we started it with, 2.807, 2.807. That's for a molecule, all these things connected together. All right? I'm going to multiply that, and what that'll do, moles on top and moles on bottom will cancel when I multiply, out and out. All right? Then I'm going to multiply this, and that's going to give me, I will try to fit it in here, 1.69 times 10 to the 24 molecules. All right? And that's molecules, again, of Li3PO4. So the next thing I want to do, I want to look at that Li3PO4, right? So now we've got the elusive third step here. We've got to figure out what's going on here. So let's look at our formula, Li3PO4. Now, before we look at that third step, excuse me, let's talk about wheels on a tricycle. How many wheels are on a tricycle? 3, right? It's called a tricycle, 3-wheeled bike. So there's 3 wheels. So if I'm in the tricycle factory and the order comes in for 1 tricycle, I have to make sure I have 3 wheels. If the order comes in for 2 tricycles, I got to make sure I have 6 wheels. 2 bikes, 3 wheels each. An order comes in on a busier day, 5 tricycles. So I got to go, okay, 5 bikes, 3 wheels each, 5 times 3, 15 wheels I have to make sure I have in stock that day. Really crazy busy day comes, right? The whole pandemic thing is over. We're out celebrating. We're able to go out on the streets now and hang out. Bikes are flying off the shelves. 30 bikes. 30 bikes I have an order for. How many wheels do I need? Well, each bike has 3 wheels. I need 30. 30 times 3, 90. I need 90 wheels. All right? So there's a relationship between the number of wheels that I'm going to order and the number of bikes ordered. Tricycles, right? So a tricycle has 3 wheels for every bike. Think about this right here. We're looking for lithium ions. Here's what we have right now. We have molecules of this. We have these molecules. And every molecule, there's my molecule. How many lithiums do I need to make up that one molecule? I need 3. There's 3 lithium ions for every molecule. So if I have 1 molecule, I have 3 lithiums. If I have 2 molecules, I need 6, because there's 3 lithiums in every molecule. So I just multiply it. If I have 10 molecules, it's 30. If I have 50 molecules, I multiply that by 3, and 50 becomes 150 lithiums are needed. If I have 100 molecules, I'll need 300 lithiums. You get the idea. those numbers are smaller. Well, now I just have a bigger number. I've got this big number of molecules, but the math is the same. All I'm going to do there is multiply it by the number of lithiums in a molecule. And there's 3 lithiums in every molecule. So I'm going to erase this. And we'll write this last step here. So I'll do the last step in green. It's still part of the same problem, but I'll do this last step in green. So it's like the additional step that wasn't covered yet. So this is a new step. 1 and 2 we've done before, they're fine. This third step is new, so pay attention to it. I'm taking this, bringing it down. So I've got 1.69 times 10 to the 24 molecules, and that's of the lithium phosphate. And I'm going to multiply that by 3 lithium ions per molecule. There's 3 lithiums per molecule. Every one of these molecules has 3 lithiums. So I multiply it, just like I did the wheels with the tricycle. And what we'll find is molecules on top and molecules on bottom will cancel when I multiply. And now it's just 3 times this. My only unit left over is lithium ions, which is what we're looking for. So it's a very simple step, right? But again, chemistry is full of this. It can seem hard at first, and then when you reason it out, you go, oh, really, that's it? Kind of like the eggs and dozens thing from yesterday or the day before, right? So when I multiply this out, I get 5.07 times 10 to the 24 lithium ions. And that, my friends, is our final answer. And it's right. All right, so I hope that last step made sense to you. Hopefully I taught it well enough so that it does. So now that's going to allow you to do every single problem on that sheet. The first 2 examples today will allow you to do most of them. There's a couple in there that ask how many atoms within a molecule or how many ions within a larger molecule. So for those ones, you might need this third step. All right. Anyway, go to work. I added a second sheet of problems today, and they're on your D2L site. If you have any questions, comments, or concerns, use the comment section below this YouTube video or reach out to me through Edsby and I can help you. All right? Chemistry doesn't have to be hard. It's really, really simple once you think it out and see the patterns involved. Anyway, hope the video helped. I'll see you soon. Talk to you later. Bye-bye.